All right, we are recording. So welcome to, I guess, the last week of school. Technically, next week is the last week of school. There's no finals in this class, though. So what you're going to have is the last couple competency exams are going to be kind of rolling around this week. And I think there's 2 up right now. Make sure you guys do those this week and next week. There's a really easy homework assignment that will finish off the semester. In fact, I think you guys have done it already. We did rainfall in class. Do you guys remember doing that? Where like you get like rainfall data entered, and like you have to throw away negative rainfalls, and then you have to average. Do you guys remember doing that in a lab like halfway through the semester? Yeah, that's your final homework assignment. So what we did together in like an hour, that's the big capstone thing. So in Java though. So but it's a pretty easy assignment. So let's learn some Java, and it's good. It's one thing to like listen to a lecture. It's another thing to actually code something in it, and you'll see it's not bad. Like let me show you how to become a Java programmer. What you do is you become a C++ programmer, and all the same skills like that. Like when you look at code, like there's just a mindset you have to get into, and there's a mindset for like debugging and things like that, and that's the main thing that you learn in computer science. The actual language doesn't matter that much. Like I was helping a student earlier, and they had a return statement above the rest of their code, and the return statement immediately would run, and it would return, and the rest of the code wouldn't run. And so you need to get into the habit of like being able to look at that and be like, oh, well, that's why my code's not working. You know, it's just habits of mind and things like that. And so let me show you how to become a Java programmer. You first become a C++ programmer, and then over and over again you Google something like this: how do I make a vector in Java? That's how you become a Java programmer. All right, let's see what the top link here is. Vector in Java. All right, that's how you do it. Cool. All right. Cool. Some demo code. All right. And what you do is you do this. You copy it like this. Control C, and you come over into here. And what was the name of the file? Because the name of the file matters in Java, right? It's called vector demo. All right. So vim vector. I always like pronouncing it that way for some reason. Vector demo.java. Havoc. Oh, copy. Oh, you're not copying. What's going on here? The whole point of doing this is so I can copy it. There we go. All right. Okay. So this is how you learn Java. Okay. So step 1, you copy from the web. Step 2, you compile it with Java C. Now, what I said before, and I'll say again, is you have to make sure the name of the file matches the name of the class. This is not at all the case in C++. In C++, the name of the file really doesn't matter. In Java, though, the rule is the name of the file has to match the name of the class, like this. Okay, it's called vector demo, so the name of the file is vectordemo.java. Okay. UCSD only taught me how to Java with pencil and paper. Really? Who did you have? Gillespie for CSI 10, 11, 12? Keeps cutting out. Can you guys hear me? Testing. Audio? 8A. Yeah. All right. Yeah, no, the midterms and finals are on pen and paper, and I graded a lot of those, back in the day. How do you copy from the computer and paste to Putty? Yours will not let you. So okay. So I've got mouse support turned off, and that allows me to select things, which is nice, because then I can just right-click and paste with right-click. That's nice. Alternatively, you go into insert mode, And come up here, right click, copy, and then in here you hit Shift Insert, and then it pastes. Or you can right click to paste, either way. So Control Insert copies, Shift Insert pastes. Alternatively, selecting something with a mouse, which you guys don't have by default because you have mouse mode on, which sucks. But students love clicking on things for whatever reason. So with mouse mode off, you can select things with the mouse. And then you can right click to paste. And you turn off mouse support. So you edit your vimrc file. Your vimrc file, which is in your home directory. If you're not in your home directory, you need to add a tilde to it. You would not believe how many students still don't know how to well, this probably not, but don't know how to copy files and things like that. I told you at the beginning of the semester, there's a tutorial on Unix, takes an hour to go through and make your life a lot easier. It's optional, it's not required. Okay. All right. It's going to make your life easier. It's not required. I'm not going to do it. That line right there, set mouse equals A. Disable it with a double quote character. So, yeah, and it's not going to go away. You're going to need to know Unix for 41, for 26, 45. It's the kind of thing where you can say it's like in my Japanese class. The professor started the class by saying, "I can't memorize words for you. I can teach you the grammar. I can't memorize words for you. You have to memorize words on your own." And she'll tell you, memorize these words by this date. And then she shows up on that date, and people don't have the words memorized. And she's like, "I don't know what you want me to do." I don't get frustrated at you guys, because it's just kind of if you don't want to take an hour of your life to save 10 hours of your life, that's your business. But, it's just kind of funny to me, because learning Unix, it's worth $5,000 pay differential, and it makes all of your life easier. So, and she looks really disappointed at everyone. Yeah. Mm-hmm. And so by the time you get into second semester, everyone's kind of a little bit arrogant, because out of the 90 students that took Japanese 1, there's 15 left by Japanese 2. And and everyone has this kind of holier than thou attitude, I can study, I do what she asks. It's kind of funny. A little bit of arrogance in the Japanese 2 crowd. A little bit, at least in some students. Okay. So vector demo.java. And so here's how you do it. Okay, let's make a new vector. All right. Oh, cool. That's, I guess, how you make a new vector. And then, okay, so instead of push back, it's called .add. Okay. All right. All right. So we're push backing some things. Vector has the following elements. Oh, you just output the vector. That's cool. All right. That's neat. Type safe vector, new vector of strings. Look, that looks pretty similar, right? Except that looks a little different, maybe. And it's capital V. All right, type safe vector, push back, except they're called add instead of push back. And then we print them. All right, good to go. And then you can try things, right? For auto s in type safe vector, system.out.println s. I don't know. Oh, print line. Let's see if that works. It probably won't. But cannot find auto. Okay, so auto doesn't exist. Do you see what I'm getting at here? Basically, what you do is you kind of just look at demo code, and you're like, oh, that's how they do that. Okay. Yep. So, can you make a function for system.out.println? It's a function. So that is your sorry, I ran a.out Java vector demo. Okay, there we go. So the default vector print, oh, that's cool. You can just see out a vector. You can't do that in C++. That's cool. Good job, Java. And it just does a square bracket, I guess, and then commas, and it just prints out all the elements. That's cool. Vector has the following elements, these. And then I used a range-based for loops. Oh, look, range-based for loops work. Ah, look at that. for every string in the vector, and it's a capital S string instead of a lowercase s string, because it's Java. You guys see what I'm getting at here? Like, this is how you learn how to become a Java programmer. You just find code that's like what you want to do. You're like, okay, I got it now. Yep. Range of for loops work. Okay. Auto? No. But, yeah, a range of for loop works just fine. So, I was going to be surprised if auto worked. I'm just going to double check that that does not work. Good. I cannot find simple. Good. All right. So, that's how you become a Java programmer. Okay, you Google something, and it's basically everything in Java. The core language is the same. All the primitives, all the basic language constructs are the same. Ints, floats, doubles. It's minor differences. With char, it's called byte instead of. And then for the standard library stuff, it's going to be similar but different, right? Everything in Java in the standard library is similar but different. And so, except there's some things that Java has that C++ doesn't have, like networking. Because, the internet's like a thing now, I guess. Like, I don't know. I hear it's going to be big someday. It may be a little bit too soon to put it into the C++ standard library, but they're thinking about it for C++ 23. They're thinking about it. It may be time for the internet. I'm a little bit sarcastic. It's because I am. Like, Java has had networking in the standard language, I think, since the beginning, since Java 1. And it's so bad in C++ that it's actually easier for me to teach networking by teaching people Java and having you guys do programming assignments in Java to do networking, to do a networking program in Java. You've never done Java before, you've never done networking before. It's actually less time for me to do that than it is for me to teach you networking in C++. That's, yeah. C++ does not have networking. C has networking. And so if you do networking in the standard library in C++, you are using C libraries. And the C libraries are just fine. They're just fine. If you're a C programmer, you're just fine. So you have an array of file descriptors, and you put them into different states, and you've got different structs, and you loop over all of the different file descriptors that are all your different things you can read from and see which one of these, F control, connect file descriptor, set FL, F control, listen FD, get FL, O non-block. Makes perfect sense if you're a C programmer. Maybe. Maybe not. I don't know. So, yeah, there's no C++ networking library. So they're thinking about adding it for C++ 23. We'll see. See if that happens. And so far, the proposals I've seen for the networking aren't promising either. So, don't get your hopes up on it. I bet if C++ added networking, it'd be confusing as hell. Yep. Yep. The proposals I've seen are not as easy to use as Java. It's really sad. It's like, well, we want to make sure it's best practices. We don't be locked into one thing. And it's like Java has had it since 97 or something, 96. And it works fine. Like, just copy them. You've copied them on other things. Why does Java exist? Java exists because it is safe. It is impossible to go out of bounds in Java. You cannot corrupt memory ever in Java, and you can in C and C++. Even with address sanitizers, there's always that niggling fear at the back of your mind that you're going to corrupt memory somewhere. You're going to go out of bounds and change a bank account balance from a 1 to a 1 billion. And yeah. Does white space matter? No. Java, remember, is C++++. Wait, sorry, that's C#. C++++ is the hashtag symbol, right? 4 pluses. No, but Java really is like an iteration on top of C++. So white space doesn't matter. These curly braces. There's one difference in Java that's worth, I guess, mentioning. Vector-demo.java. X equals 0. If x system.out.println hi. That's not what I was trying to show. Yep. Java does not allow you to use things that aren't Booleans as Booleans. So that's something that constantly irks me in Java. You cannot treat an integer as a Boolean. So for this one, you would have to say if x is not equal to 0, like that. And it just bugs me. It just bugs me. Because Java is a verbose language. Java, I always joke, has a kickback scheme with keyboard manufacturers so that they get a 5% sale of every keyboard sold to a Java programmer because they wear out their keyboards so much. So, why not teach Java then? Because we teach C++ is the answer. We do teach Java. It's easier to learn C++ than Java as a serious answer. It's easier to go C++ to Java than it is Java to C++. And that's just the truth right there. So, you tell it's an Aspen because it's the way it is. Yeah. But seriously, it's because Fresno State teaches C++. Is the real answer. If you think that there's like some sort of like rational reason why colleges teach the languages they teach, you're gonna be disappointed. Most colleges teach what everyone else is teaching. Well, what do they teach? What everyone else is teaching. Well, what do they teach? What everyone else is teaching. You might think it comes from places like Berkeley, but no, Berkeley teaches like Scheme or something that nobody uses. Harvard and MIT all have their weird, intro languages. It's this weird group mentality because you want to teach the most popular language, and so everyone just kind of like is doing this thing, like, oh, which way should we go? Which way should we go? And it's just herd mentality. There's no rhyme or reason to it. I mean, arguably Python's good for beginners on day one, just because with Python you can, print 5. Look at how nice that is. X, 56. Look, day one you can be writing programs without a program. You don't even have to have a text editor. Just run it. So. Why is everyone so crazy about Berkeley? Well, Berkeley is one of the top number 1 schools in computer science. There's like a bunch of them. MIT is, Carnegie Mellon is, Berkeley is, Stanford is. I think it's either like a 4-way tie or a 5-way tie for first place. It's kind of dilutes the meaning of the number 1 school, in my opinion. But the reason why it's number 1 is because it's number 1. It's really, it's like I'm giving you another non-answer, but it's actually true. Like, they have their pick of all the best computer scientists in the world to apply to them, right? MIT does too. And so all the best programmers in the world that are the most, gifted, hardworking, they've done projects since they were -5 years old, apply to your school, and then you get to cherry pick off the best ones, right? The ones that would not make Kozasa Sensei sad by not studying for the class, right? And so when you get the, top people, then they produce top work. It's just how it is. There's a really depressing study that, and it almost doesn't matter how you assess students. The A-level students will somehow end up getting an A, and the B-level students will somehow end up getting a B. So it almost doesn't matter what you do. It's a little bit too negative, and I do think there's ways of fixing that, but Crazy story, hard to get into, no benefit except sticking the name on your resume. Yeah. So I've had students graduate from Berkeley, and the homework assignments they give there are not very interesting. Like, it's a lot of like mathy stuff, you know. They don't do Pokemon, you know, and stuff like that. They don't do image processing. They don't do anything fun like that. It's just program set over program set, kind of like Zybooks, you know. Yeah. Basically, the questions, Zybooks, kind of. All right. Like in the past, is one of the only ones to teach C++ and not anymore. Stanford is the only one that still teaches C++. It's an option. You can either take your intro class at Stanford in C++, Java, or Python. It's the only one of the top 10 schools that does that. All the other ones, it's all Java and Python. I went through all 10 of them. Yeah. Yeah, okay. So, yeah, I mean, when you graduate from Berkeley with a computer science degree, you are very hireable. One of my students who went to Berkeley, he went to Berkeley, but he was at Buchanan in 2015, I think he graduated from Buchanan. He came in and talked to me before the pandemic, and he's like, yeah, I'm working at Chase Manhattan now. I think they offered him $170,000 starting out of Berkeley. It's not bad. Would I ever teach at Berkeley? That's an interesting question. Like, one of the professors there has like asked me out for lunch a few times, and I've just not been able to meet up with him. And that was pre-pandemic too, so who knows if that invitation is still on the table. But I don't know. It would be fun, I think. I really don't like the Berkeley area. Like, it's kind of... It's a lot of graffiti and potholes and stuff. I don't know. Kind of gloomy. Yeah, I don't know. I kind of like Fresno. So. All right, so let's go over Java. Yeah, so you learn Java by Googling it. No, I'm kidding. I'm kidding. You learn it because I'm going to teach it to you. But like this thing right here, you know, I learned Java by going through, they have like Java trails or whatever. Yeah, Java tutorials. And so like if you actually want to sit down and learn it, this is the place. I'll post that on the chat channel if you want to actually learn it. But yeah, you can learn Java by just like you try to do it the C++ way, it doesn't work. And then you're like, how do I do an unordered map in Java? Okay, you guys with me on this? Like, do you guys understand that? Like, it's the same thing. It's just named something a little different. Instead of pushback, it's .add, right? Like, it's just a matter of like, okay, that's how they do it. Okay, cool. All right. So let's go over the actual presentation, and that's probably good as well. Okay, so here's hello world. So public static void main string bracket args is your boilerplate. This has to be the name of the file, so this has to be in a file called hello world.java. You compile it. I don't know if you guys saw how I compiled it. Use javac, javac, and you pass in a .java file that produces a .class file with the same name. And then you Java it by typing Java vector demo like that. No .class, just vector demo. And when you run vector demo, it loads it from the vector class file and runs the code. Okay. So you don't out, you always run it with Java like that. Okay. So, differences. So what I've done is I've kind of gone through the entire language, and anything that's different from C++, I've highlighted it in red. So that's kind of the part you need to sort of pay attention to. Pushing off tutorials, get better grades. I'm lazy. If degrees aren't that important, I'll push back watching them because I'm lazy. Degrees are important. I mean, they're not, but they are. You know what I mean? Like, if you have a bachelor's degree in computer science, that will at least get you your foot in at the door at a lot of companies, because it means you're supposed to have a certain degree of competence in computer science. So You should know how to do this and this and this and this and this. Okay. If you don't have a degree, then they don't know if you've like taken discrete math yet. You know what I mean? If you have a bachelor's degree in computer science, you've taken discrete math. And they know you've taken discrete math because it's required. Basically, if you follow the ACM curriculum guidelines, you will have taken discrete math and theory of computer science and probably operating systems and data structures. And, there's a certain curriculum that is core amongst all computer science programs. And that's what they're looking for. Like, they don't want to have to, like, explain, like, what an operating system is from scratch. That's what a degree does. That doesn't get you the job. It gets you the interview to get the job. Okay. And if you don't have it, you can still get a job. You just have to like demonstrate, like you have to show a lot of work experience. I've done this. Okay. And then they interview you, and the interviews are mostly CSI 41 and CSI 26 questions. So, like linked lists, like they come up a lot for whatever reason on job interview questions. We don't use them, but they come up on job interview questions. Reverse a singly linked list. Okay. My sister works at Weed Maps as a graphic designer. A coworker does website programming there. Doesn't have a degree, but he did tell me it's definitely harder for him to get his job foot in the door. Yeah. Yeah, and that's how it is. Like, a degree is just, and by the way, we don't, just because you have a bachelor's degree, doesn't mean you actually know anything. Right? That's why it's a job interview and not a job, right? The job interview is so we can be like, all right, now let's find out, did you pay attention in CSI 40 and 41 and 26? It's 4 years later. How much do you remember about linked lists? And that's why a lot of colleges nowadays have a senior class that's a 2-unit class that is a job interview class. And so basically, one of my friends is in it right now at Monterey Bay. And basically what you do is you sit there and solve job interview coding problems for 6 weeks or whatever, and get, because it's been 4 years since you've done linked lists. So time to refresh, which is kind of a cool thing they do there. You can learn a lot of CS Online on your own. Yeah. But again, a degree just shows you've had the curriculum that we expect from every computer science major. And if you have a master's degree, that means you have a higher level of knowledge expected of you. And if you have a doctorate, there is a lower level of knowledge expected of you because doctorates usually are hyper-focused, specialized in one particular area, and they're not actually that good at all of computer science because they took the curriculum and then they spent the last 6 years studying how to make code and routers go faster. And they know that really, really well. I can reprogram the firmware on an ASUS router to make it route things 10 times faster, whatever. That I can do. If you ask me to reverse the singly linked list, not at all. And that's the unfortunate reality of doctorates is, like I was talking to a headhunter, a recruiter, and he's like, I don't hire PhDs from computer science. I hire master's students, preferably. Because master's students know how to program. PhD people know their one thing, and they know it really, really well, with like a very laser-like intensity focus. So. It's like they're throwing all the kanji neglected to see if you remember the stroke order. Yeah, that's a good way of putting it. And also like a degree from places like Berkeley and things like that. It's there's a prestige element to it. If you have a master's degree from MIT, there's a prestige element to that will help you get the job, especially if you're going to go into academia. So like if you're interested in becoming a professor or something like that, having a degree from like Berkeley or MIT will definitely get you you'll at least get called in to interview. It won't get you the job, but it gets your foot in the door. And that's a big thing. It's important. It's important. Okay. Kearney suggests you get a master's. Yeah, definitely. A doctorate, maybe. It depends. It depends what you want to do. But a master's, I would say all of you guys should get master's degrees. It's by the time you get your bachelor's, you've seen everything a little bit. you've had 10 weeks of operating systems. Is that enough to know everything in an operating system? No. No. Operating systems like Windows and Linux are incredibly detailed and complicated. And in your first 10-week class, you're going to go over the basics of it, And then when you get a master's degree, you take it again, and this time you go into detail. You know, and so by the time I finish my master's, I'm like, oh, okay, I finally actually kind of understand what's going on here. That's cool. You know, the bachelor's degree, you've had like a little sprinkling, a little dab, a little dusting of like all these topics, and then in a master's, you take all the core subjects again, and you actually kind of understand them at a deeper level. That way. You also get paid more for a master's. That's true. Also, debt. Here I come. What do you mean debt? Debt. What do you mean? I don't understand, Gonzalez. Do you think it costs money to get a master's degree? No. No. Negative money. Negative money. Nobody in the master's program paid $1 unless they wanted to. Depends on your college. That's something to find out about, is how much support they have. But lots of money come into computer science programs. Corporate money funds research. And so all that money flows in. Like UCSD gets $1 billion in corporate dollars a year. $1 billion of corporate money a year flows into UCSD. So think about that. Divide that by the number of grad students. Okay. So no, your high school didn't say that. Of course not, because like they didn't know your computer. This is different for English, by the way. If you want to get a master in fine arts, you're gonna go into debt. You know. 40,000 a year or something like that to get your MFA, and there's no support for it, you know, or very little support. For computer science, literally nobody in the department paid unless they wanted to. Like my buddy, he paid because his work was paying for it. So who cares, you know? But what you do when you're in grad school is you work either as a TA or as an RA. TA, you teach a class. At UCSD, you're not allowed to actually teach a class. You are able to run sections, but you can't actually do the lectures. A lecture has to be done by a professor at UCSD. At other colleges, they'll actually have TAs teach the class, which to me seems a bit shady. You know, like the professor just kind of blows off the class and just lets the TA handle the workload. But you do most of the grading. Like you do sections where you stand up and you essentially give a lecture. You know, but it's not an official lecture, and students don't have to go to it and stuff unless they do. And if you do that, you don't pay tuition. So they waive all of your fees if you are TAing for that quarter. And then they give you $19,000 a year in, 20 years ago, dollars, whatever it is now. It's probably higher. So, master's in business, you're going to pay for it. If you're going to get an MBA, you're going to pay for it. Sorry. But if you get a master's in computer science, it's free. It's negative money. So I actually stayed in the department probably a year longer than I needed to, strictly speaking, because I liked studying. I liked taking classes. I was getting paid for it. Life was good. I had an apartment, I had a car, had food on the table, So how do you apply for it? You just say, I want a TA, and then you TA. Yeah, sorry, unhappy face, Margaret. Yeah, if you're going to get an MBA, they're going to charge you for it. It's a cash cow, for sure. Especially executive programs, things like that. They're milking the students for money, for sure. Yeah, so that's a TA, and then for an RA, you do research. And so the way that academia works, and I will get back to Java in a second, I promise. The way that academia works is that a professor writes a grant. If you want to get tenured as a professor, you have to write grants. I was at Duke, a program at Duke online in the spring, and they brought in a dean, and the dean's like, yeah, if you want to get tenure at my institution, you have to bring in $1 million into the institution in the 4 or 5 years until you're up for tenure. If you don't bring in $1 million, you're fired, essentially. We don't want you to be fired. We're going to work with you. But you need to bring in $1 million. So that's, the sad reality. But the good reality is that when that much money is flowing in, basically what happens is a corporation will... Like, I was supported by Sun Microsystems. I didn't know this, but I was. When I wrote my thesis, they're like, oh yeah, put down thanks to Sun Microsystems on your thesis. They were funding you this whole time. I'm like, oh, that's cool, thank you. Yeah, sure. And what happens is you do research. And so your professor has all these research interests. They're doing research on corporations fund it because they want to take the research and use it, right? So I was also funded through Procter & Gamble. And Procter & Gamble they had all these models of heart cells that were in like Fortran and C, and like they weren't portable or anything like that. And they wanted them ported to Java because, how do you think I learned to become a Java programmer? They wanted ported to Java because all of these programs were like for one specific operating system. It runs in Fortran 77 only on a Sun OS computer. And what they wanted was all these things put into Java, and Java, you can write it once and it runs anywhere, theoretically. And so they paid for me to port all these different biological models of the heart cells into Java so that they could do research with it and not have to bother with all this, like porting it and compatibility issues and things like that. They were a total pain in the ass. And so they paid the professor a lot of money to do this. Because they would have had to hire a team. I don't know what the exact total was. I think it was probably like $300,000, something like that. And he, from that pool of money, hired me. And it was a 3-year project. And unfortunately, I got it done in 3 months. So the rest of the money, I guess he just kept. I don't know. I think there was $100,000 allocated for my position. $30,000 a year, I think, was what was allocated for my position. I got it done in 3 months. I got paid like a quarter of $30,000, like $7,000 maybe, something like that. Out of the $100,000. Got it done too soon, man. Got to stretch that out a little more. The professor loves me. Like, he wrote me a letter of recommendation and everything. But, yeah, I didn't know how the thing would shake out, but, But here's the deal. Like, so when that money comes in, when you do research for a professor like that, they give you a tuition waiver also, if the department has the money for it, which the computer science department did. And so tuition waiver, you don't pay any tuition or fees or any of that stuff, and they hand you money. Cool. And so basically to get those positions, which are highly sought after, but there was a lot of them also, is you get in with a professor. So you become friends with a professor. Like, you take, especially like if you're an undergraduate and you become a graduate student, or you're a grad student, doesn't matter. You take a class, you're like, oh man, I really like this, operating system stuff. I want to do it. Or I really like compilers. I want to do this more. You just talk to the professor. Like, in grad school, there's like 15 people in a class. It's not gargantuan. You just talk to them. You're just like, hey, this looks really interesting. There's something I want to work on with you, And then they'll either tell you to, like, get out of here. No, they don't do that. But they're like, oh, yeah, sure, yeah, there's an opening in my lab. Yeah, we'll bring you on. We'll set you up here. Sit down here. And you fill out the paperwork. You don't pay tuition anymore. They hand you money, and then you basically just do whatever the professor wants, for $20,000 a year, whatever the inflation-adjusted amount is nowadays. Just like you talk yourself out of that job moving a robot arm. I know, right? Like, what would I do the rest of the summer? Not the right question, apparently. Not the right question. All right. Like, I could have worked. That was the place they made the first PlayStation. Sony, that could have. I straight up just talked myself right out of that. Yeah. Okay. So Java. Anyway, long story short, get a master's degree in computer science. That's my recommendation, because it's negative money. It doesn't cost money. Undergraduate, yeah, sure, costs money. Undergraduates are cows that colleges milk. But grad students are the people that make the farm or the ranch operate, right? So the professors are like the people in the office at the ranch, and then the grad students are the people that go out there and like do all the dirty work. They have to do all the grading and all that kind of stuff, and they milk the undergraduates for money, and then 4 years later, all right, here you go. They put a little laurel on the head of the little graduation cap on the cow. All right, get out of here. They just sit there and they just milk up. The undergraduates are they're cash cow. Right, but it's the grad students that make the whole system work. Because professors hate grading. I'll say that myself. That's why there's an auto grader. Because I hate grading. Like, you saw how long it took the RPG assignment to be graded. It takes a really long time. And so the grad students do all that, right? And so they want support for the grad students. You're the favored cow when you're a grad student. Okay. All right, it's a weird analogy, yeah, but I mean, you know, I was talking to a professor at Fresno State the other day and said the same thing. It's the same analogy I use. You know, Cromwell, sorry, executive MBAs, they're cows, cash cows for the university. Pays the bills, keeps the lights on. Okay. Don't want to take the GRE. The GRE is the same as the SAT. GRE is easy. Can't imagine a professor, even a teacher at K-12 likes grading. It's brain numbing, is the way the head of Fresno State's computer science put it to me. It's like, it's brain numbing. Yeah, so, auto readers, good stuff. All right, Java. Let's do this. So, differences between Java and C++. In C++, we have a char type. The char type in C++ is a weirdo. It's a 8-bit integer, but every time you see out it, it doesn't output as a number, it outputs as an ASCII code, which is a really odd. It's a really odd design, because sometimes you want to use a char as a number, like an unsigned char for like your image processing assignment, like all the RGB values are 8-bit chars, 8-bit unsigned chars. If you try C-outing the value, it comes out as a letter or something. It's really irritating. So in Java, they fixed that by having the 8-bit integer being called a byte. A byte is 8 bits. And then they still have shorts, 16, int 32, longs 64. There's no long, it's just longs. And these are fixed. In C++, these numbers are fluid. And so sometimes you can have a 16-bit integer. Sometimes you can have, yeah. So in Java, they're fixed. An int is always 32 bits in Java. Floats are always 32 bits. Doubles are always 64 bits. They have a Boolean, which is true or false. So a bool. And then they have a char, but the chars are 16 bits because it's Unicode or something like that. Okay. Do they have multi-precision boost? Google. How do I do big ints in Java? I don't know. How do I do big ints in Java? Let's find this out. Big integer class. It's in the standard library. You see that C++ people? Right there. That's what I'm talking about. That's what I'm talking about. Useful stuff in the standard library. Right there. You don't have to include, you don't have to link in GMP, all this kind of nonsense. Like, Java's standard library is actually nice. Whereas, you know, C++, they're like, oh, C++ 17's come out. What should we add? Should we add big ints? No, let's add the ASOC Laguerre ref and ASOC Laguerre. What the hell is that? I don't even know. Computes the associated. Like, give me a big int and networking. My lord. And matrices. I'm going to rant about this for a while. So, do Booleans still need a byte? Booleans are either true or false. That's what they are. Do they require a byte of storage? Probably, because most variables don't. You can't really store a variable in less than a byte. Is the way that most computer architectures work. Is JavaScript the same as Java? The same way that carpet is the same as a car, as the joke goes, which is to say, no, not all. String is capital S instead of lowercase. Variable names are the same as C++. You can have a $sign, but nobody uses it. You can have uninitialized variables in Java, but you can't use them. So this is actually something I really like about Java also. If you have an uninitialized variable like that, it compiles just fine. Okay. If you try using it uninitialized, it's an error. It's not a warning. It's an error. It will not compile. You cannot do anything unsafe in Java. It's really nice. And frankly, I wish this was a thing in C++ as well. Like, there's really no call to use an uninitialized variable. You know, like, some people try using uninitialized variables like random number generators and things like that. It's a terrible idea. Because the optimizer will look at it and be like, oh, it's an uninitialized variable. It's 0. Done. You know? It's a horrible source for entropy. Why does everything on the net use Java? It's safe. It's safe. That's, they need safety more than speed in some domains. And things like that. It's a nice feature, and I just really wish that C++ would implement some of these things. Okay. Then they've got the box types. They have capital I integer, capital F float, capital D double, and these are classes that pretend to be an integer, or pretend to be a float, or pretend to be a double, because they kind of are under the hood. But there's nice things because they're classes. You can call like toString on them. So if you call toString on Bob here, it'll be the string 7. It's nice, I guess. Instead of const, you have public static final, because again, Java is verbose. Java is a very verbose language. Public static final instead of const. C++ would be better. No, I mean, what do I know? Because like there's a lot of considerations that goes into making a language, and like they want to get networking right, and I kind of get that. At the same time, Java clearly did something right because we're still using it 20 years later, and it's going fine. Maybe copy that design. I don't know. But they've got 2 competing designs for networking right now, and neither of them are good in my opinion. But, what do I know? Big difference between Java and C++ is you cannot have a stack allocated array in Java. In C++, this is fine. It gets allocated on the stack. It's actually nice, by the way, to be able to put arrays on the stack, because the stack is very fast to allocate. The stack pointer moves down, the memory is allocated. You return from a function, the memory gets deallocated. New is a slow function. And so if you're doing something a lot, having to new things is actually fairly painful. So there's a performance benefit to be able to stack allocate things. Java does not allow it. No delete. There's no delete on Java, just new. Java only has new, no delete. Just new. The reason for that is because the language itself handles the deletion. That's the core point of Java, actually, is that they're like, deleting things is too hard. Newing things is easy. Deleting things is hard. So we're going to make a language where it'll just figure out when things aren't needed anymore and call delete for you. It's like a smart pointer in C++. A smart pointer in C++ allocates memory, and then when it goes out of scope, poof, it deallocates itself. It's nice. Implementation details are different under the hood, but that's the same basic general idea. Okay. Yeah, so what happens in Java, there's something called the garbage collector, and the garbage collector runs periodically. And whenever it runs, it frees up any things that were newed that are not used anymore, and you'll see your memory usage drop. And then the memory usage will go up, and then when the GC runs, the garbage collector runs, you'll see a bunch of memory get freed up. Okay, so yep, you can allocate memories these 2 different ways. They got multi-dimensional arrays like this. Yeah, in C++, every new needs a delete, and in Java, you don't need it. It's kind of nice. Kind of nice. It's also kind of garbage for gaming and things like that, because the garbage collector pauses your game, so there's like a little hitch, And so, like, who uses Minecraft? Like Jensen, I guess. Have you ever like seen like the scripts to like launch Java Minecraft? Like how they have like all these flags for like the memory aspect of Java, like how much heap and like the garbage collection settings and things like that. Yeah, it's super annoying. It's super annoying, and that's because it's not designed for gaming. So you have to really tweak those parameters in Java so that the garbage collection doesn't hose your frame rate. Or not even frame rate, it just hitches. Like, it's super annoying if you're running down the street and it pauses, and then you're running down the street and it pauses, and you're running down the street and it pauses, you're like, So, yeah. Functions are the same as C++, but there are no global functions. Everything has to be within a class. So, like, even if I was going to make, like, an absolute value function like I did last time, even if I was going to make an absolute value function, it has to be within a class. Like it can't go up here. Everything is inside of a class in Java. And that's because the file name is vector demo, right? And everything inside of this class has to be in a file with the name of it. So there's no free functions. And the reason for that is so you know where everything is. So in Java, if you ever, use a vector, it's in a file called vector, right? Like it makes everything easy to find. And so that's there for a reason. And we could like return if x is greater than or equal to 0, return x, otherwise return -1 times x. Works fine, by the way. What? The ternary operator? Yep, ternary operators in Java too. Like I said, the core language is pretty much the same. Yeah. Libraries are in classes. Yeah, libraries are literally a file system. So when you import java.util, there's actually a folder called Java. And inside of that folder, there's a folder called util. And inside of that folder, there's other folders. And this says import everything from the /java/util directory, and it pulls all of them in. Okay. Is there something like CPP reference for Java? Yeah, there's a lot of documentation for Java. So let's spend another few minutes on this, and then we'll go over the homework assignment. No operator overloading. This is something I do not like about Java. So there's no operator less than, there's no operator plus, there's none of that. You can't make two different classes that can be added together or anything like that. It's not possible. Everything's a function instead. So rather than a plus operator, you make like an add function or something like that. What happens if you import Java star? Then it adds everything, I think. Yeah. All the operators are the same. C++, there's plus and minus and times and divide, and all the operators in C++ are in Java. Same thing. There is one different thing, which is the triple right shift instead of the double right shift. We haven't learned shifting, I don't think, so it doesn't matter to you. Order of operations, exactly the same. All statements end in semicolons, exactly the same. All code blocks use curly braces, exactly the same, and can be omitted if they have one line of code. Right? Right? Same code. Exactly the same. So, for loops are the same, expressions are the same, semicolons are the same, the curly braces are the same, if statements are the same, if else is the same, switch statements are the same, while and do while are the same, for loops are the same, range trace for loops are the same, break and continue are the same, return statements are the same. See how easy this is to learn the language? This is all hard when you're learning in C++, but for Java, you're just like, same code. Easy? What do you guys think? Core languages, like, some minor differences. Byte versus char, things like that. Basically, the core language is, it's the same. The standard library is different, right? So is this function Java or C++? It's like math square, but they might have imported it, so probably both. If it was Java, they've imported the package for it, right? So, yeah. A lot of times you just can't tell if code's Java or C++. They're that similar. Python, you can tell, right? Python, you can tell. Java, C++, C# to a certain extent. Okay. Yeah, one thing is you can't stack allocate any class. Everything that's not a primitive has to be nude. That's a big difference. It's something that takes a while to get used to coming from C++. You can't just you can't just be like jobs bitfield jobs. No, you can't do that. Everything has to be nude if it's a class. Don't care. Oh yeah. We talked a little bit about that last time. If you do a /**, that is Javadoc, and that actually will generate documentation for your code, which is pretty cool. You can put a note that a function is deprecated. If you do that, then It's kind of cool. So deprecated means don't use this function anymore. So if you compile it, it'll what is it? Is it lowercase d maybe? Lowercase d. No, capital D? No, lowercase d. Lowercase? I'm gonna spell it. Doing something wrong, but whatever. Doesn't matter. What you can do is you can actually tag your code. It's really cool. It's gonna bug me. Capital D maybe. Okay. So, so you notice that even though I have deprecated code, nothing happens, right? What is deprecated code? Deprecated code means this is an old function. You should not be using this function anymore. It's fine. It's fine to have your old code in there because it doesn't break backwards compatibility. But if you ever try like using it, like system.out.println absolute x like that, then it's fine. That's not G++. If you ever try using it, then what happens is cannot be referenced. Public static. Yeah, either. Basically, it'll throw a warning that you're using old code. So it's a neat system where you basically say, hey, don't use this function anymore. You should be using a new function. So it's kind of cool. It's a warning. It's not an error. It doesn't break anything, but it's a way that you can sort of send a message to people who use your code. Don't use this function anymore. There's a better one. There's absolute 2, absolute unit. Okay. It might be deleted in later versions. Oh, they got rid of it. Deprecated itself is deprecated. That's funny. Okay, fair enough. All right, so it's a cool thing how you can like leave notes for people who use your code to not use your code. They use import instead of hashtag include. Okay, so I'll push out the Java directory, but basically your homework assignment is going to be doing Rainfall, but in Java. Okay. So here's a summary of changes. There's no pointers in Java, by the way, or technically everything's a pointer. Everything that's not a primitive is a pointer, technically, under the hood, sort of. Doesn't look like it though. It's like when you make a variable of class type, you knew it, right? New returns a pointer. Java just doesn't have the star. That's the difference. So everything in Java that's not a primitive is a pointer under the hood. Yeah. They just hide. So there's no arrow operator. It's a dot. It looks like a regular variable. And so what they did was they just said, all right, nothing's a pointer. It's a pointer. It's a pointer, but it's not a pointer. It doesn't look like a pointer, but it is a pointer. But stars are scary, so we're just going to make it look like a regular variable. No arrow operator, just dot. So arguably, it's actually a good change. Like I actually kind of appreciate it. When everything's a pointer, nothing will be. Yeah. The only thing that gets you is that makes everything call by reference in Java. So whenever you pass something like this to a function, it's called by reference. Anytime you pass a primitive, it's called by value. And Java doesn't really have that same mechanism of saying, I want call by value, I want call by reference. it's just all objects, all class types are called by reference, all primitives are called by value, and that's just how it is. And if you forget that rule, you know, Lord help you. Okay. Whenever in super, nobody is. Exactly. So, yeah, but it's, you know, people are scared of pointers, so we'll just make everything a pointer under the hood, but make it look not like it looks like a regular variable. It's fine. It's not scary. Come to Java. No operator overloading. You import rather than using include. The document Java doc's really nice. If you do this /*, you can, anything that goes inside of that goes into the documentation automatically. It's pretty cool. And garbage collecting. You new things, you don't delete them. So that's Java in a nutshell. Let me push out the directory to you all. So see the deploy homework. Set 40 Java. And so this is a little demo hello world kind of thing here. And it's got a summary of all the things we do in C++, right? So everything we've learned this semester: how to do input and output, how to make a variable, how to do algebra, how to do if statements, how to do loops, how to do functions, how to do arrays and vectors. Right there. Demo code and all this stuff. It's good. You're going to need it for the homework. How to do classes and how to do file I/O. So these are all the things we've covered in this class. This demo file that I pushed out for you has the complete documentation of how to do everything we've done in C++ in Java. Okay? You guys all hear that? So, this isn't your homework, it's just demo code, but this is a complete summary of everything in Java. Okay. And then your homework is going to be sudo homework, csci40. Yeah, so all that demo code is in Java, right there. So this is your homework. So your homework assignment is in Java Rainfall. And right now it prints out welcome to Java Rainfall. Clean, make, what's going on here? Warning. Interesting, all right. Huh. What are you complaining about, Java? C. Pull out Java. Why? Warning. Never seen that before. It's the exact same line of code. I wonder if it's running. I don't have an alias set up. They're just warnings, so I don't know. And so anyway, so yeah, you can type a.out. It's kind of funny what I did. I made an executable called a.out. But it's not executable. It's literally just a text file that says Java Rainfall. It's in your directory. You have a copy of Java and you have a copy of Java Rainfall. And so this is an executable. It's a text file that says Java Rainfall. So when you type a.out to run it, it runs the program. Did you guys know you could do that? You can literally make a text file, and the text file is just a line of code, or a line you can type from the Unix prompt, and it runs it. It's kind of cool. So yeah, Unix, you can just make a text file, and if you set the execute bit on it, chmod everybody may execute a.out like that. If you set the execute bit on a text file, like let's make a new text file called Bob, and say echo csci40. It's great. So this is a command you can run from Unix, right? So I made a file called Bob. Now, if I tried running Bob, you can't run it because the execute bit's not set. But if you set the execute bit on Bob, it's now a text file that you can execute. And so when you run it, it runs whatever's in it. And so there's a lot of easy scripting you can do. Like if you have a bunch of commands you run over and over again, a really nice thing you can do is just put all the commands into a text file, set the execute bit this way, and then you can just run the text file, and it'll do all the commands one after another. It's really nice. Unix is amazing. All right, so let's take a look at the Rainfall Java assignment. This is what you're given to begin with. Okay, so you're given hello world. All right, you're given hello world. That's it, and you need to do rainfall. You're more than welcome to look at your old code for rainfall. Hopefully you kept that. And you need to write it in Java. So what the rainfall assignment is, if you guys don't remember, is you start off by typing in rainfall data, 5 millimeters of rains, 100 millimeters of rain, 0, 0, 0, 5 millimeters, 100. If any negative numbers come in, you discard them. It's like negative 100 or whatever. You discard it's a bad reading. If a negative 1 comes in, that means we're done. Terminate the loop. And yeah. So, and then all the other ones you add to a vector. So you're going to need to Google, how do I make a vector in Java, like I did earlier in the class. And just all the rainfall that you enter goes into a vector. Somebody needs to make Kearney clips of just when I'm talking about random things like Berkeley and stuff like that. That'd be funny. And then after the user input period is done, then you go into a menu of 5 options. Option 1, print the average daily rainfall. So what you do is you add up all the elements in the vector. You can use a range-based for loop. Add up all the elements in the vector and divide by the size. Done. Average rainfall in rainy days. Add up all the numbers that are not 0 and divide by the number of days that were not 0. Okay. Count of days that had rain. So same thing. Go through the vector, see how many non-0 days you had, print out that number. All of these things can be done a couple lines of code. Maximum rainfall. Go through the vector, find which one is the biggest. Top 5 days of rain involves sorting it. I've already included the header file you need, so to speak, here. Java has a sort function that's within Java utility collections called sort. And so you just sort the vector and print out the top 5. Okay. And that's your last homework assignment. This will be due in a week. Get this done. That's it. Just a couple competency exams left, and you're done with the semester. So I'll take requests for Wednesday and Friday. If you guys have any topics you want to talk about, we can go over them. Then you want networking, security, whatever. Just free for all. I'll answer any questions about this. Yeah. Life advice: go to grad school in computer science. Security, sure. These are ints. They're ints. Yeah, they're all ints. Get a master's degree. Yeah, that's my advice. Yeah. It's, and do it sooner rather than later. A lot of people graduate and then they go like, "I'll go back to college." It's hard. It's hard to go back to college when you got a wife and a kid. You know, like, sorry, honey, I'm not going to be making any money for the next 3 years. Yeah, it's rough. It's rough. It's hard to do. You can do it. My mom did it. It's rough, you know. Night classes and stuff like that. Yeah. So I would recommend just plowing through, getting your master's and a doctorate if you're interested in it. Depends what you want to do. If you're interested in research, if you're interested in academia, if there's like one topic that is like your burning passion, then yeah, get a doctorate. There's nothing wrong with it. We just have to be alone. Rough. Okay, so that's it for today, guys. Thanks for coming out. Does this seem doable to you? It's like a for loop. Range-based for loops are going to be your friend, by the way. So, yeah, you got a week to do this. It's something you already did in lab, so just in Java. That's the only twist. Sadly, yeah, it's doable. How's that sad? Right. Okay. All right, sounds good, you guys. I'll see you guys on Wednesday. And again, if you have any ideas for topics for the last 2 days, post on the chat channel, and I'll whip something up. Cool. All right, peace out, you guys. You're so sad you learned Java. It's good. It's good for you. It's good for you. See you.